As people often say, 3 days in coldness, 4 days in fine dust. Fine dust has become a serious problem in today's life. Massive-scale coal-fire power plants are suspected as one of the key culprits. Influencing factors include many different air pollutants containing dust that get scattered when loading and storing coal, and the exhaust gas generated when burning it. Coal is fed from the coal storage yard and undergoes mixing and pulverizing processes to be ground, which is then combusted inside the boiler and generates hot exhaust gas. This gas contains pollutants such as dust, nitrogen oxide, and sulfur oxides. Power plants have sophisticated environmental facilities to remove these pollutants. The exhaust gas passes the selective catalytic reduction process to remove nitrogen oxides, and it is transferred to the electrostatic precipitator, commonly called the EP. Using the power of static electricity, the EP is highly effective in collecting dust and mist from the exhaust gas. After passing through the EP, the exhaust gas is fed to the flue gas desulfurizer. There, limestone slurries are sprayed in the absorption tower to remove sulfur oxides from the exhaust gas, which is then discharged to the atmosphere through the stack. Power plants run these environmental facilities to get rid of the air pollutants in the exhaust gas. Most of the dust present therein is removed while going through post-combustion processes before the exhaust gas is discharged from the stack. In accordance with the enforcement decree of the Clean Air Conservation Act, stack of power plants have automated measuring devices for detecting dust and air pollutants running 24/7. However, they target only dust particles 50 micrometers or smaller. While measuring and controlling fine dust and ultrafine dust is increasingly important, no legislative or institutional arrangements have been developed regarding the measurement of fine dust in exhaust gas discharge from the stack of power plants and factories. Hence, there are difficulties in estimating the amount of fine dust discharged. Recognizing the absence of technologies to measure fine dust discharged from stacks and in response to the need to have control over fine dust discharged from power plants and factories, the KEPCO Research Institute developed automatic continuous measurement technology of fine particles and succeeded in developing and optimizing an automatic continuous measurement system of fine particles that is attached to a stack of thermal power plants to measure fine dust specifically by particle size. The automatic continuous measurement system of fine particles consists of a cyclone component that samples exhaust gas right before it is discharged, a pre-treatment component for high temp and normal temp dilution to prevent the condensation of hot exhaust gas, an optical particle counter that employs light scattering measurement techniques to measure dust content in the diluted exhaust gas, calculate concentration by particle diameter, and display measured values, a controller and auxiliary components including a compressed air system. The controller controls the flow and temperature of diluted air fed to the sampling probe and the monitoring of fine particle measurement data in real time, and the results are saved automatically. Other features include settings for cleaning time and intervals to ensure stability in long-term operations and wireless communication-based remote monitoring and control of all functions. The KEPCO Research Institute has completed long-term stability evaluations at many power plants in Korea and plans to disseminate the system in thermal power plants increasingly across the country. This marks the establishment of a technological foundation that enables accurate fine particles emission estimation at both local and overseas thermal power plants for the health of humanity and Earth.